Wow, we're now on 10.4, yay! And we've been doing all kinds of functions. We did y equals x plus b, linear, y equals x squared, quadratic, y equals the square root of x, rational, y equals p of x over q of x, rational, and now we're at exponential functions. Exponential functions deal with y equals some number raised to a variable. All right, well, first let's look at exponentials to begin with. They are a base value raised to an exponent. And then from that, we know it is repeated multiplication of the base value exponential times. All right, there we go. All right, so we can say 5 to the third means 5 times 5 times 5, which equals 125. So 5 to the third is equivalent to the product of 125. All right, but before we go there, we notice this rule that was given to us from our textbook. Exponential function with a base of a is defined as a number that is greater than 0, and a cannot equal 1, a to the x. And what we have here is exponential rules. And we need to review them a little bit so that you understand why this formula says what it says. So in the exponential rules, or properties is a better mathematical term. All right, we have a to the n, an exponent, times a to the m, another exponent, is a to the n plus m. All right, so this is called the product rule. And then we have this guy. A to some exponent divided by the same base to another exponent is equal to a to the n minus m. Logical, right? To multiply, we add. To divide, we subtract. And this is called the quotient rule. All right. And then we have probably the most important for what we're doing. A to the 0 is always 1. A to the 0 is always 1. All right. So this is called the zero exponent rule. All right. And now we come to another one that's very powerful. And this one is also an understanding. A to the, that means the base number raised to an exponent and then raised to another exponent. It's the product of those two. And this is the power rule. And the last one I need to tell you is x can be any number, and therefore it can be a negative. So what does a negative imply? Well, it says that any base number raised to a negative 1 is the reciprocal rule, 1 over a to the 1. So it's a fraction of it. And this one is one of the ones that we use quite frequently. So let's first start off with graphing. All right. So what I want to do first, before we make a selection, is look at what it says. Y is 5 to the x. Okay. So let's make a t-chart. I'm very good about making t-charts because I need you to know that we insert things to try to figure out what we get. Well, I want to do a -1. So if x is a -1, we have 5 to the -1. Therefore, y is 1/5. This is the reciprocal rule. So what is happening here? It's small, right? So let's do 0. Ooh, that's that 0 rule. Y equals 5 to the 0. That means y is 1. Okay, by the 0 rule. All right. Well, if we have 1, y equals 5 to the 1, well, then we have 5 is 5. All right, now we can see that it was small, getting larger, and we're getting almost there. And notice that we can't reach 0. 0 is never a consideration in an exponential unless it has a movement after it, moving it up or down. Okay, so let's look at the next one. Let's do 2. Oh my goodness, so we have y equals 5 squared. Well, then it's 25. Now look at that. I mean, it just gets larger and larger. So if we were to draw this guy, then we're going to use our calculator because I made you buy it. So we had -1, 1, and 2. All right, and 0, of course. So at this point, if this is 1, 2, 3, 4, and 5, okay, let's just do that. Then we have 1/5, which is about right here. At 0, it is 1. At 1, it is 5. And at 2, it's way up here, 25. So we can see that it never touches a 0, and it goes up like that. All right, well, let's do our calculator, because that's what I made you buy. So we're going to clear what we worked with last time, and we're going to enter 5 up caret x. And I'm going to go with zoom 6 for starters, and that's kind of big. And we can see it looks like ours, keeps on going higher and higher. Well, let's do second calc value. Second calc value, and we're going to do our -1, and we get that doggone 0.2, which is 1/5. Then we can do our 0, and I get 1. We can do 1, and I get 5. 2, and I get 25. Even though we don't see it on the graph, it will do it. So now they want us to match that graph. Well, we immediately know it's not a line. We immediately know it's not a radical. That's a square root type thing. And this one is a cubic, so we know it's not that either. So let's look at what it is. All right. Show you what I'd like you to see about working with this computer program. And that's to recognize that it has a domain, and it is -5 to 5, and range, remember, bottom to top, -5 to 5. Okay, these are all the graphs that we have. Now, we kind of know it's that one. We know it's not this one. We know it's this one, but we want to match. So I'm going to get my calculator, go to my window. I make sure it's a -5 and then a 5. Then I come down here to the y minimum, because that's this part, -5 and 5. Okay, and then I hit graph. And we can definitely match this guy right here. And our solution is that one. Okay, now see how much we learned. This was a line. This was a radical. And this guy had 1, 2 turns. So it's a polynomial. And it's odd, because it goes from -infinity to +infinity. All of this you've learned up to now. So we want to take this guy. Now, what's different between this guy and the one we did? First off, we have a reflection. Four to the -x. And then this part says we have this is reflection over x-axis. And this one is over y-axis. In other words, we're moving it on the opposite side. And then this one, the 2 is a movement up. So we can have a 0 of the whole function. We're moving it up 2. All right. So what is my template? 10 by 10, right? -10 to 10. -10, sorry about that, to 10. Domain, range. All right. So this means we can put it in the calculator and match it. But we can look at this and kind of determine. Notice that they're all radicals. Exponential functions. Sorry about that. And each of them dealing with what we have. So we're going to go to our y equals, clear it. We're going to enter what we see. 2 minus 4 up caret negative x. Make sure we hit the negative. All right. Now I hit enter. Now I'm going to go zoom 6 because it's a 10 by 10. Looky there. So we know it's not this one. Let me go in the front. All right. And we know it's not this one. And we know it's not this one. It is this one. Notice that we said a reflection over the x. That means downward, across, instead of it being up. And then we a reflection over the y. That means that the positive small numbers going upward is now downward. And then we said it was up 2. And there it is, up 2. All right. Pretty awesome, right? Okay. So we went through graphing, and now we're talking language. Where is this applied? Because we're in business math. And so what do we have here? A ream of 20-pound paper. This is just the weight of it. 500 sheets, the quantity is about 2 inches high. Suppose you take one sheet, fold it in half, then fold it in half again, continuing in the way as long as possible. All right. So if we have a ream that is 500 sheets, and it's about 2 inches high, and we look at this guy, and they want, suppose you take one sheet, okay, half again. All right. So let's see what happens here. And we're taking, suppose you take one sheet. So we have one sheet of this paper. If we cut it in half, or fold it in half, we have 2. If we fold it in quarters, we have 4. So the basic number is 2. So we have the function f of x equals 2 to the x, x being the number of folds. So in this case, we have the domain 0 to infinity as a number of folds, and they are in integer form. In other words, they are whole numbers. All right. So that's all we needed on that one. Exponential function, f of x equals a of x. Negative values of a were ruled out. The author of the textbook in mathematical economics, however, obtained a graph of y equals negative 2 to the x by plotting the following points and drawing the smooth curve through them. Right. So here we're talking about an exponential. All right. So we can see that if the exponential is even, it's positive. If the exponential is negative, it's negative. If the exponential is even, positive, odd, negative. So it's called oscillating. Graph oscillates neatly from positive and negative values of y. Comment on this approach. This exercise shows the danger of plotting points when drawing graphs. All right, so let's go with this guy right here, and we're going to enter it. We're going to say parenthesis negative 2 raised to the x, because that is our function. And we're going to graph it. So what happens here? Well, first off, we can't even see it, okay, because it is so small. So let's change our window to negative 5 and 5, and oops, sorry, did it both on one. Negative 5, enter 5, and we're going to see, I don't know, I think I have to go smaller. And then I'm going to go from this one to a negative, let's do a negative 2 to a 5, and see if we can see something here. And we can't see it. So the concept of doing an oscillating implies that it is continuous when it is not. It is just points. Well, we can possibly go even smaller, okay? So let's go with a negative 2 and a 3, because that's a scale of what we're doing. Negative 1/16, okay, a negative 8, because that's, we're talking the y value, and a 1/16. I mean, this is really small, right? Oh, sorry. Negative 8. Let me do that division. So we're going to put it as a 1. All right, and delete that. Let's see if we can do it. And we still can't see it. Oscillating is difficult, and it is not continuous because we're talking about exponentials. And exponentials can be negative, but they're all whole numbers. So that's what we learned from that. If a is greater than 0, a cannot equal 1, and a of x equals a of y, then x equals y. So now we're talking about solving equations. So what this says, if the bases are the same, then the exponents must equal. So we can find a relationship between exponentials. So here we have for the x. So if I did 64, I have 8 and 8, right? I did a factor tree. 8 and 8 is 64. Well, this is 4 times 2 times 2 for the 8. So what I have is 4 times 4 times 4, because these two that. So this means I have 4 to the x is 3. Therefore, okay, again, we're looking at solving, must equal 3 to b. By that rule, by the rule. All right. So there you have that. Now, you could have done it by the calculator if you wanted. In other words, we could do 64 divided by 4, divided by 4, and we got 1, 2, 3 fourths. Okay, one or the other can work. So, this one's tricky, isn't it? It's a 4, and this is 4 squared. So what do I have here? 4 to the x plus 3 equals 4 squared times the 2x minus 7, because this is that power rule. All right, so we're looking at this mathematics and seeing what we have as a solution for this equation. So we know that the bases are alike, therefore x plus 3 must equal 2 times 2x minus 7. We're going to do a little bit of math on this one, nothing serious. 4x minus 14, distributive property. I'm going to subtract the 4x. I'm not worried about the negatives just yet. I'm going to subtract the 3. That's a negative 17. I'm going to divide by that negative 3. Therefore, x must equal, and 17 thirds. All right. Well, we want to check that, see if I did the math right. So we're going to enter 4 up caret, and I'm going to put my answer 17 divided by 3 plus 3. In case I made a mistake, you know. And I'm going to hit enter. I get this ugly number, and I'm going to do it on the opposite side. 16 up caret, and I'm going to be doing 2 times 17 divided by 3. I hope I put 3. Yes, I did. Good. Minus 7. And I get it. And looky there. Both identical. Again, you're always verifying. Don't just trust your math, because you know, as you've been with me, I can make a mistake. And so you want to make sure the answer is correct. Now, in this case, we want to graph the following equation. And right here, we have to consider E. Now, I didn't put what E is, so let me do that first, because we have E. E is an irrational number. What does that mean? And what that means is it never ends and never repeats. It's a natural number. It's known as a, excuse me, having difficulty with my throat. It is known as a natural number. Now, offhand, I don't remember the mathematician who discovered this. It's like pi, okay? So pi is an irrational number as well. Well, this one's used heavy in finance. Better put it correctly. And that's where we're going to. So let's look at this number. Okay, well, on our calculator, we're going to do ln for natural log. We're going to do second ln, and we're going to put a 1. And you can see it only shows 10 digits, so we can't see all of it. But you can see that it is a funny number. And we don't ever shorten it, because that's why I made you buy a calculator that can do this kind of mathematics. So it's an irrational number, and it follows the same rules as a base. It looks as a base. So we're seeing it as a base. In this case, so we can say that e to the 1 is approximately 2.7182818, blah, blah, blah. Okay, so we want to graph this beauty. And in graphing this beauty, we want to use simple numbers that give us real values. All right, so what we're going to do with this, and we're going to do it manually first, and then we'll do it by calculator. And you have choices here. But I'd like you to see the math first. We want to do -1 because that's an easy one to do. So y equals -3e to the -3 times a -1 plus 1. All right, let's see if I can do the math. E is going to be a what? A +3 plus 1. All right, when I do this guy, I'm going to use my calculator on my home screen because this number right here is pretty big, and we're going to do an approximation. So here we go. -3 second ln 3, and I got to put the side arrow plus 1. Can't leave it all in the exponent, and I get this ugly number. And I'm going to round it to 1 decimal because it's bigger than my graph. So I'm going to do 0. Well, that's beautiful. Okay, so this means y equals a -3e to the -3 times 0 plus 1. Well, we know anything to the 0 is 1, so I have a -3 plus 1. I get a 2. -2, sorry about that. So I get a -2, don't I? All right, well, what happens with a 1? Because we have a negative value, we're going to have an exponential. All right, so here we go. And again, we're just approximating what this thing tells us to do. And we're going to use our calculator for sure. So I'm going to have a -3e to a -3, which is a reciprocal value, plus 1. And we're going to use our calculator. -3 second ln to the -3. And I got a side arrow, make it back down, plus 1. And I get 0.85. So I'm going to say 0.9. And it's positive. All right. So, again, we're not going to have a good view of what we have, but we know that at -1, it is way down here someplace. And then at 0, it is -2. And at 1, it is 0.9. So we've got this kind of line going like this. All right. Because the exponent goes into the negative values as to the negative infinity, and then it tapers off here, reaching a maximum type or a horizontal asymptote. So let's go with our calculator now, and we're going to clear it, and we're going to enter the -3 second ln -3x. I go the side arrow plus 1, and we're going to graph it. And there it is. And you can see we got the -2, And we got that 0.9, all of it like that. And it tapers off at 1. I made it too high, I think, but it tapers off at 1. Sorry about that. Like that. Getting closer. All righty. So there you have that. So we're going to be going to that when we start looking at finance. So this is our compound amount. This is a formula. If I had time, I would tell you the app to use. But for right now, we want to use this concept for compounding amount. All right. So the P, well, I'll write it down here. P represents the principal. All right, it's the amount invested. The R represents the rate of interest. Now, it can be a loan as well, but we're going to say amount saved. Rate of interest. It's a percent converted to a decimal. Right. Then we have an M. They do an M. Other books, it might be an N. And that is the amount of interest compounded per year. All right. So this guy right here has the following concepts. And you might want to write these down on your notes so that you'll understand. So we're going to have our M, and then we're going to have number of periods. Right. So if they say annually, that means the interest is compounded one time a day. If it says semi-annual, then it's 2. Quarterly is the more normal. It's 4. Monthly, this one is done on payments for ease of calculation of interest that you owe them. Monthly is 12, because there's 12 months in the year. And continuous is E. Right. So now I mention what E is on this section. It is M becomes larger and larger. That means it grows and grows and becomes closer and closer to the irrational number E, which was this number right there. So we're going to do some math here. And now I'm going to do it by construction. And I think that's better than me teaching you something on the calculator. So I'm going to do it on the home screen. So remember our formula. Our formula is P, parenthesis 1, which is the principal, added to how much interest is earned for TM dollars. All right. So our formula. Oh, and I forgot to mention A. I am sorry. A, going back, I apologize. A is known as the future value. So here we have, we want to find the interest earned for $25,000 invested for 4 years. This is my T. This is my R, 5% compounded annually. So M is 1. All right. Everybody ready? This is my P. We're looking for A. And then subtracting the A from that. Right? And so we have this. Sure, I have my formula correct. I don't want to tell you wrong. TM. All right, got it, got it. So we're going to do first, right. So my future value is going to be the $25,000 at the 1 plus 5% is 0.05. Okay, divided by 1 raised to the 4 times 1. All right, so I'm going to clean it up. Divided by 1 is the anything, and this is what I put in the calculator. So here we go. 25, 1, 2, 3, parenthesis, 1 plus 0.05, close parenthesis, up caret 4. Our future value is 3038.7, and we're going to round to 2 decimals, 66. Okay, now this is the future value, the total. So we're going to subtract the initial to find interest. So he made $5,387. Okay, because they wanted interest earned. All right. Next one is semi. Right, so that means M is 2. So we have A equals $25,000, 1 plus 0.05, and this shows you divided by 2 raised to the 4 times the 2. I'm going to clean it up. And this is going to be 0.025. If I divide the 5% by 2, I get that. All right, just so long you know, and this is 8. And this is easier for me to put in a calculator and for you to see. 2, 5, 1, 2, 3, parenthesis, 1 plus 0.025, close parenthesis, up caret 8. At dollars, 2 decimals. It looks like 07. And Now this is what we have as our total. So we're going to subtract the 25,000. And we can see that we earned, oh, under $100 more, right? All right. So we're going to do quarterly. Quarterly means that M is 4. All right. Now we're getting more interest. It's a smaller amount of interest per each quarter because we don't want to exceed that. But compounding is how you make money on anything. And you can see the pattern of it. All right, I'm going to clean it up. Now on this one, it's even smaller, 0.05 divided by the 4, and I get 125. 0.125. And 16. Now remember, we started what? At 4, 8, 16. Each time we're doubling the number of payments of interest per the period. So now we're going to put it in our calculator. Now, the reason I'm doing this and not using the app is because when you do get to finance, there's all kinds of programs that are given to you in your line of work. So I just need you to see how the formula works. Now this one is 24 cents because the 8 is larger than 5. So here we go. So this is my total. Now I'm going to subtract the initial investment. And again, our interest is, now we earn $50, well, 30-something dollars more than the previous one. All right. So then they're asking us for monthly. Oh my goodness. So let's make some room here. Now we're doing monthly. So my M is 12. So I'm going to have A equals that 25,000, parenthesis, 1 plus 0.05 divided by 12 raised to the 4 times 12. All right. We're going to enter this. This one is a long decimal, so we're just going to enter this in the calculator. And the only thing I'm going to clean up is that 48 as my exponent. 12 times 4 is 48. So here I go. So I'm going to enter. Let me clear everything because this is a little bit longer and I want to make sure you see it. Open parenthesis, 1 plus 0.05 divided by the 12, close parentheses, up caret 48, and enter. This is 38. All right. So this is 35, a little bit more, not a whole bunch more if you notice. So this is my total. I'm going to take away the 25,000 to know how much interest I made. 255. All right. 5497 5522. You can see each time I'm getting more interest earned on the money investment. Well, the last one is continuous. Now the continuous can only be done on the home screen. It is A equals P parenthesis E to the RT. Sorry. Right. Because it's continuous, and that's that exponential we drew. All right, so we have the 25,000 E raised to the 0.05 times 4. All right, so let's just put it in. So I know it's going to be a 0.2, but let's just put it in. And here we go. 25, 1, 2, 3, second ln for the E, and it's 0.05 times the years. And I get all right. So my total in my account will be 35. Now notice it's very slight on that. If you get monthly, that's probably okay. And I'm going to subtract the 25,000. And you can see from the 22 we upped it to 35. So that gives you an idea of the power of compounding. Compounding interest is what you want to get, and at the highest interest rate possible. All right, so here we have a growth, and that's the other use for E. We use it for growth and decay of certain items. So here we have our account, and you can see that our initial value is $3,200 raised to this interest times T. And so here we go. And this is for population, because that's what this is. But you can think of it as the same thing as what we had with the P. All right, so this is growth. The population of a species was 3,788 million in 1970. This is 10 years from that point. How closely does a function approximate the value? So we're checking. All right. Now, see what it says. This started in 1960. So we want 1970 minus the 1960, and we get 10 years. So our T is 10 years. And our function is A of T, the time, years, of the 3,200 initial population in 1960, E to the 0.0166 times the 10. All right, and we're going to match it to the actual 3,788 million, because this is in millions. All right, so let's do it. On the home screen, 3200 second ln, and we're going to put the 0.0166 times 10. All right, because that's what it is. And I'm going to get and for this one, I get 3,778, because you can't have a piece of a people, right? So you're going to get about that. So let me see if I got my numbers. Yes. All right. So now the actual, and this is in millions, the actual was 3,788, and that's pretty close. It's off by a few. Right. So let's see what else they said. They said, use the function to approximate the population of the species in 2000. Okay, now here we have another actual. So we're going to say for the B, 2000 minus the start, 1960. So that looks like 40, doesn't it? And the actual was 6326 million. All right. So we're going to do our formula. Right. So all we have to do is change that last one. So there's a trick I can do called second enter, and then I can go backwards back here and change it to 40. Well, it's a little wider gap. The difference here, the 100 million. So now it's a little wider gap. It's not doing the job as well, but it's not too bad when you get to that million. Okay, so now we're going to estimate for 2015. So we're going to take the 2015 and subtract the 160. Sorry, 1960. Sorry. Well, we know it's 40, and that would make it 55, wouldn't it? All right. So we're going to go our A of 55. And if you don't believe me, we can always do it on the calculator, and always good to be safe for you. All right. Yeah, I know you have to see it sometimes, and I don't mind. Again, we're going to use our second entry. Oops, sorry. I can't do it, can I? Second entry. Do it twice and I get there. And I'm going to make it 55. And I hit enter. And I get approximately 79, 73, 74. Okay, the population is approximating to that number. So, so we have all of what we need. We were comparing the formula. It was pretty close, not bad. Usually when you use a formula of growth, it's only good for, oh, I don't know, maybe 10 years. And then you have to recalculate with actual values, which is why we take a population every 10 years so that we can predict within the next 10 years how much the growth might be. Is it always true? No. Economics and flight and all kinds of things happen to impact our formula. According to a recent census, a certain country is becoming more diverse. Based on the census population projected for 20,000 to 2050, the projected population of minority in millions can be modeled by the exponential function of this, where t equals 0 corresponds to the year 2000. And t has to be between 0 and 50 inclusive. Answer parts A and B. Well, I didn't write what A and B is, so I'm going to have to tell you. So we want first short amount, approximate we want to approximate 2004. Minority population. So we want f of 4. If I could read my type right. And again, we're using our home screen. I'm going to clear that. So we want to write in our item 37 and 77 time parenthesis 1.035. Oh, I didn't put my point, did I? Good job. And I'm going to raise it to the 4. And I get 43.34, blah, blah, blah. So approximately 43, and this is in million. Well, the actual, so the actual in 2004 out to be okay. So, because it was that problem there. Okay, our B. Let's see our B. I wrote that down. Problem. I have my B, but I do have my C. Read it again, F of T. All right, 37. All right, so we're going to do the B, which is, okay, this was our minority group at 20. And at 37.77. All right, now, what we have now is the 45 as 45 and 64 hundredths, and we're going to subtract our initial 37.77. To find the change, and the change is 7,908, sorry, and that's 4, 7, 7, 7, 8, 7. So 7.87 divided by 20.8. 37, sorry, the change, 3777 gives us approximately, and we'll do it here. That's how it happens when I don't type out what I'm working on, right? You'll see it on this problem set. And that gives me a decimal 20836 on and on. We're going to do a percent, 20.8% increase in the population. That was the last question, because the prior one was what was our population number against what the initial was. So there you have it. Now you can do the homework. If you have any questions on anything, please let me know. All right. Do your homework.